Righty then. So here's the plan. I'm going to go into my LOLCODE Babel macro, and we're going to finish up the other, how many? I think I said there's 16 node types that we still have to implement. We're gonna write tests for those and then implement them, and that should be that. Then we have a very neat way of using LOLCODE inside JavaScript, which is infinitely useful and a great addition to the ecosystem, right? So let's see. We're gonna start with looking at lol.js, which is what we were doing before, and we're implementing our compiler over here. So we have the JSify class, which I'm going to move into a new method, or just a new file, because that's going to make life easier. So we say const JSify equals required dot slash JSify. Okay, and we create a new file, paste that in, module.exports equals JSify, save source JSify.js. Hey fuzzy buddy, how are you doing today? Macro.js, we don't need the compiler stuff anymore, so we can remove that. rm-rf source compiler. That was an old attempt, and let's make sure that it still works. Yarn test. Excuse-moi. There we go. It prints out function console log hi world when we input code that looks like this. So if you write import lolcode const code blah, it says, it turns into a function that, you know, returns stuff. So now we're going to write more tests and basically just make sure that all of the different nodes actually work, and then we can take it from there and implement the nodes themselves. What's the time zone in New Zealand? Or rather, what time is it there? So I'm going here. We need assignment, break, breakpoint, cast, declaration, function call, function definition, gimme, identifier, if, indexer, loop, loop condition, no op, return, and switch. So it sounds like a lot, but I think it's fairly doable. So I'm going to start by 5:46 p.m. That's not too bad. So I'm gonna start by writing the rest of my tests. So blah blah blah, error false. I have no idea how any of this works, but I'm going to set up stuff for copy pasting. Basically, that's basically what I'm doing right now. So I'm setting up code so that I can copy paste. We say hi, we say k thanks bye, and then I don't actually know how the LOLCODE specifies all of these things are supposed to work. Language structure and examples, Houston Chronicle keywords, similar code was printed, blah, example. I want to find let's see, parrot virtual. So I'm trying to look for, I guess what I need is the actual language spec. So what's LOLCODE? Great question, fuzzy dude. LOLCODE is a esoteric programming language that follows the old internet meme of lolcats, if anyone still remembers those. I'm kind of dating myself. This is like a 12-year-old meme now, but it's a great meme and I love it. But basically stuff like this. So let's see. I has a var. I'm in your loop. LOLCODE. No. Let's see. Let's Google LOLCODE, and I'm sure we're gonna find something useful. lolcode.org. Language, there we go. LOLCODE spec, perfect. Spaces are used to demarcate tokens. We don't care about that. Variables. to be revisited and refined. Naming, declaration, and assignment. Types, booleans, numerical types. Actually, you know what? We can make our life easier by just looking at Mark Watkinson's implementation of LOLCODE. And we're basically taking his compiler and his interpreter and translating it into a compiler, essentially. So here he has a bunch of handlers. Where are they? To yarn, this tick, blah. Where are they? Okay, so we're going to go, basically we're gonna go step by step through his implementation and change it into a compiler. So we still need assignment, breaks, we don't need breakpoints, body we have, we need cast, we need declaration, function call, function definition, gimme, identifier, if, indexer, we have literal, loop, loop condition, no op, return switch, and we have visible. Cool. So I'm gonna go through. So we said this is assignment. This one is going to be an example of a breakpoint. This is going to be of a break. An example of body we have, cast. Then we need declaration, function call, function call, function definition. So I'm basically writing small examples of LOLCODE so that we can use those to write tests. Function definition, gimme. So I actually prefer mechanical keyboards, and you may have seen it before, and I'm actually using an ergonomic mechanical keyboard to do this stuff, to do all of my work. Identifier, if, indexer, I have no idea what an indexer is. Indexer, we have literals, loop, and then we have loop condition. I guess loop and loop condition are probably related, but yeah, they're probably very related. Loop condition, where was I? No op, return, and switch. I missed one, but whatever. We'll see when we're implementing it. Okay, so we can start by doing an assignment example. So let's see, evaluate assignment. How do assignments work? Where did you learn React, React Native, and Redux? Did you take a course or just sat down and read the pages of documentation they have? So it was kind of a combination of things. I personally learn best by just reading some documentation and then trying things out and playing around until I figure it out. So that's kind of what I did. I read some documentation, I did some experiments, and I played around, tried to implement a bunch of things, and that's how I learned React and Redux and stuff. By basically just trying it out and reading other people's code. Okay, so if I go to LOLCODE, assignment, aha. Okay, so we can start with a declaration actually. So declaration says I has a var, and then how do we, aha. I don't know how snapshots work, so I'm just gonna try kind of faking it. So exports, macros, what was it? Declaration, macros declaration 1 equals, yeah, I'm really not very sure how this stuff works, so I'm just gonna try my best. We paste the code here, I think, and we want that code to translate into let's say const code equals function, where we want to say let var so var starts, should we yeah, let's define it as null. Everything starts as null in our implementation of LOLCODE. So now if I run yarn test, I should have a failing test for the assignment declaration. And oh, a bunch of them appeared. Okay, cool. So if I look for assignment, okay, that's very confusing. Aha, not implement. Okay, so we have a failing test for declaration. Perfect. So now we can go into our macro.js, or rather into our JSify. So JSify, that's this one, and where we are compiling an assignment is takes a node and returns what? Let's see. I wonder how I can run a specific test. Does anyone know that? If anyone on the stream is familiar with Jest, please tell me how to run a specific test. lol.js. Okay, so an assignment. How does assignment work here? Actually, let's look at what the assignment node has. Console log node, and I'm actually going to look up Jest runs single test. Perfect. How do I run a single test using Jest? Jest blah minus t. Okay, so if I say yarn test minus t assignment, what happens? Please run just that one. No. Oh, okay. No, that worked. It skipped a bunch of them and it ran assignment, which did stuff. Package JSON. We also need to run it with. Okay, let's see. So macro test. No mac index. Where was I? Macro.js. Then we go into JSify, which needs to follow the React stuff, and we say, let's run console log here. Console log hello world, just so I can see that I'm actually printing stuff. So we're running silent false coverage and all of that, and we're getting our console log. Perfect. All right, so I can now go here and console log node, and let's say node so I can see it better. Run that. Ba-ba-da-bam. There we go. Where is it? So why is that not printing? Okay, let's console log the node name. Console log name node dot underscore name. Why is my node not printing? That's weird. It usually works. Name body, and then body. What is body showing? Console log node.lines. Why is that not working? Okay. Name body. Why doesn't body have any lines? That is strange. Let's see what our source code is. Compile LOLCODE. So console log source. Let's see what is the actual source when we run this. It should be It should have all of the source code, but I guess maybe it doesn't. Hi and why is there no source code in my test? Oh, what? How did that vanish? Where did they put it? Can no, I has a var. Oh, it's in a declaration. That's what's wrong. Okay, I'm running the wrong test. So we are actually looking for a declaration, not for an assignment. I am dumb. There we go. So now we have I has a var, and it runs a declaration, and then stuff stops. So if we go into JSify, name body, name declaration. So we don't have this yet. So I'm going to comment it out, and we're going to say declaration equals node blah, and that console logs our node like that. We don't need that anymore, and we don't need to console log the source. Let's try it again, and now it should, well, it's not gonna work yet. It's just gonna tell me what the actual node is, and then we're going to translate that node perfect. So we have a declaration node which has a var and a value. Perfect. Or it has a name for the declaration. So what we want to return is return let node.name equal null, right? And now this test should now pass. Let's see. What am I drinking today? I am drinking Rainbow Unicorns, and I feel like they should start sponsoring me for that. Okay, so that still failed. Where am I? Still console logging the lines here. And macro.js returns function let var equals null, which is what I'm expecting. So why isn't it passing? It's not passing because declaration I has a var is expecting let var null. So let's try that again. Now it should pass. I guess on the first, I'm not sure why. Let's do a -u. Let's see if that updates this let var. Yep. Sweet. Okay, so that's working now. Cool. We got the declaration working. -t, what's the next one? We want, so it's not great that I'm testing this against snapshots, but whatever. So we have declarations. Now that we have declarations, we can test assignment, right? Because once you declare a variable, you can then assign to that variable. So assignment says I has a var, and once we have a var, we can assign to it. Let's see, where did LOLCODE go? LOLCODE var r equals 3. So var r 3. So we want var r3 to assign the number 3 to the variable. So we can now run the assignment test, and we go into index.js, and this is essentially the rest of the stream is going to follow this same pattern. We're going to go node by node and implement each node individually, and that's going to magically create a compiler from scratch, which is really great when you think about it. Like, it's a cool way to create a compiler, and it's going to make an interesting blog post about the general approach to building compilers, I think. We will see. And I don't know, maybe this doesn't look that great on a stream, but whatever. So we have the name, and then the value is another node. Wonderful, which makes sense because each value, so the value of a variable assignment can be many things, which means we have to run recursion on that. We're going to keep compiling. So we go like this: return return node.name equals this.compile node.value. So node.value is a node, and that keeps compiling. So this is what I really like about working with ASTs or abstract syntax trees in general, is that each individual piece is relatively simple, but then when you put it all together, you get a very complex behavior. So in this case, we have a node that has a name, which is just an identifier, and it also has a value, which is another node. So we run recursion on that node while we're able to just use the name directly. And you'll see that has powerful results afterwards. Or, yeah. Bam. So var equals 3, and if we update that, so you can see what it generates. This is going to rewrite itself. So see, you have assignment. Hi, I has a var r3 k thanks by const code equal is a function that runs our code, let var equals null, and then var becomes 3. Now if let's see, I wonder how, if I can do 3 plus 3. We can try that later, but actually let's just see. So I go 3 plus 3, and let's see what happens when we run that. It should, in theory, this should just work automatically, but it might not. Aha. Okay, so LOLCODE doesn't have infix operators. Does it? Operator. Calling syntax precedence. Ah, the basic math. Oh, okay. So you have to do a very strange way of doing 3 plus 3. So we will deal with that later. But let's see. So we have assignment. What's the next one? A break. How do breaks work? Maybe break isn't that useful. Let's do cast. What is a cast? Cast untyped. Oh, so this is going to be a typecast of some sort. But maybe we can borrow this implementation then. Evaluate break. Okay, so we don't need break, I think. Intentionally, no one picked it up. We're not in a loop switch, so breaks are not a thing. We're not going to be using that. Let's see, how do evaluate cast. Cool, so casts have multiple types. We can do that. So we have truth, noob, yarn, number, or numbar. Let's see. What are we expecting there? So we can look here. Truth. The variable types that LOLCODE currently recognizes are strings, that's a yarn, integers, which are numbers, floats, which are numbar, booleans, which are truths, and typing is handled dynamically until a variable is given an initial value. It is untyped, which is a noob. Very interesting. Okay, so we have boolean, truths, fail. Okay, let's see, how is this guy handling it? Okay, so we can say I has a var truth var, and then we can say noob var and number var, number var, and nothing else. So let's see, does that follow? Oh, it can also be a yarn. Okay, yarn var. So this should be all of the different casts. So in our macro, no, not in our macro, in our JSify compiler, we can go here. So cast gets a node, and each of the nodes does what? Let's see. Borrowing from here, we can say node. Okay, let's console log our node and see what it says. We run the test for casts, and we shall see. Okay, I was getting hot, so I had to turn off the heater. So parser parse, expecting new line, noob truth. I don't know how to. I think LolJS comes with examples as well. So let's see. Examples, source. No, it's in test. So test. I just want to see how to actually use programs. Operators, bf.lol. I wonder what OMG does. OMG. Wow. Truth. Number. I has a char, I has a num, give me char, num, r, ord, tape, pl, not both same tape. Wow, that is very confusing. Oh, by the way, this is an implementation of an interpreter for the esoteric programming language brainfuck. Very nice. So we have brainfuck written in the thing. Visible both same, any of win and fail, and by the way we can define our own functions which work a lot like operators. Visible smoosh. Okay, so by the way must be a way to define a let's find LOLCODE examples on the internet, or maybe this one has some. Truth? No, I'm just trying to see how we are actually supposed to you know, yeah, because I don't know how I'm supposed to be casting something. LOLCODE typecast example. That seems reasonable. As a lang for LOLCODE. Tutorials point, of course. So truth. That's not giving me an example of how to write the code. So I'm trying to tutorials point, truth, LOLCODE syntax, truth, come on, number, number, int this I has a type variable. Oh, okay. Okay. So we can say I has a var. So I has a var should be what if we say I has a truth var? That should be I has a truth var. I guess that doesn't really make a lot of sense in when we're compiling to JavaScript, does it? Expecting identifier got has a var. What if we say I has a var2 and we say var2 are truth of var? That might be a way to typecast. Let's see what that does. So right now I'm having trouble because I don't actually know how this works. So source, no, not lol.js, it would be lol.js JSON, truth, win, truth return type, truth AST literal to lowercase, win fail, AST, truth, no, cast, what if we say var r win? What does that do? Var equals true. Okay, that worked. So that works, but var number, is that's one of the types, isn't it? So I'm going to just mimic whatever this guy is doing because I have no idea how the type system works for LOLCODE. Let's see if I was able to correctly write the number one. Var number, no. So I don't actually know how typecasting works, which makes it very difficult to write a test for it, but I know that no, I have no idea. Oh, I know. We can go to 99 Bottles, which is a really great website. 99 bottles of beer. So this is like the coolest website in the world. We can search languages, and it's got a 99 bottles of beer implementation in pretty much every language in the world. Using functions if and switch. So true, no, number, visible numbers, oh, that's gonna be based on the LOLCODE spec. So I has a beers, it's 99. I'm in your loop, nerf in your beers, different beers and 99. Oh really? Yeah, really visible beers, bottles of beers on the wall, OMG. Oh, I see, both same beers and oh blah blah. I have no idea how this works. I mean, I have LOLCODE example with typecast. LOLCODE tutorial on GitHub, of course that exists. Progopedia, encyclopedia of learn LOLCODE in Y minutes. Truth? Booleans. Variables are declared using the syntax I has a variable name. To declare and assign in the same steps, syntax is I has a variable, its value, blah. To assign to a LOLCODE is a dynamic list, so variables don't have fixed type. A variable's type is the same as the type of the value it is currently storing. The variable types that LOLCODE currently recognizes are strings, integers, floats, and booleans. until it is given an initial, it is untyped noob. Truth variables can only have when or arrays are not supported. So yeah, I have no idea how to write a typecast, so I'm going to just do whatever this implementation here is doing and hope for the best. So apparently each node actually no, I'm just gonna leave no casts because I don't know how to write a cast. So we're going to go out of a cast. Declarations we have. Function calls. Ooh. How do we do a function call? Function call. Okay. LOLCODE. Function call. A bare expression without any is a legal statement. Function call. Evaluate function call. Blah. Man. Functions. Declaring a new function, declaring a function, calling a function. I is yellow MK. How is I select move your move? How is I is yellow? Found your yellow if you say so. By the way, calling a function I is yellow MK. Okay, so we're going to say a function call is what? So we're going to just call a function that doesn't exist. I is yellow MK. So that should be a function call. Let's see if it is. -t function call. This should give me an error saying that function calls aren't implemented yet. Throw error, not implemented, function call. Yes, we got a function call. So I can now go back to my JSify and say function call equals node. Let's alphabetize them because we can. So a function call is a node, and let's see, console log of our node. Yarn test. We're gonna see what the node actually looks like, and then we can implement that as a function call. So we have so our function call I have no idea. This is a really hard language to understand. Damn. So the name of the function is I, right? Oh, okay. So we're going to call this, let's not say I is yellow. Right? Wait, let's go back to our AST, not our AST, but our JSON. And we're going to say function call identifier arglist argend. So this is the identifier. This is the function we're calling. I is yellow MK. Right? Function. LOLCODE functions. There we go. Let's try this one as well. Definition, how is I function name your definition of a function, returning value, calling function. I is the function name, and then expression 1 and expression 2. Okay. A function is defined in the body of a program and is later called for execution. A function which accepts a given number of arguments is called as, while calling a function, the expression is formed by the function name followed by the number of arguments. The above function that performs multiplication of input, how is I multiply your first operand and your second operand. Visible I is multiply your 2 and your 3. Sweet! Congrats for getting everything done before the deadline, fuzzy buddy. I is... Got it. So, okay. So the function is yellow, and it doesn't have any operands, which means we have a function call, but the name is actually wrong. Huh, interesting. That would mean that our parser is wrong, I think. How is I returning calling I is function name. So I think we found a bug in the LOL.js implementation that we are using, or in the parser implementation. So let's open that. Okay, and here where it's generating the parser, write file sync into the parser lol.js JSON. Let's look at the parser and look for I is, or just is token. There should be a tokenizer somewhere. Come on, where is the tokenizer? Aha, these are our tokens. So switch, avoiding name collision, initial blah, e off. Okay, so if we look at the JSON thing, here there should be I is, but there isn't. Is there an is? So aha, function. So function call identifier arglist argend. I think this JSON file is wrong, but I also don't know how to fix it, which is kind of annoying. So we are gonna have to deal. LOL.js. Okay, let's do random coding. Go back to LOLCODE Babel macro. I'm going to try to expand this. Oh, maybe it's because the function isn't defined yet. Let's do how is I. No, wrong thing. Wrong. I is yellow. Okay, so how is I is yellow if you say so, and this is going to just say visible yellow. Let's see what happens when we run that parser, or when we parse that program. Maybe there's state in the parser and it's going to now know that is yellow. I is yellow, visible yellow, expecting new line, comma. how does I, maybe that's gonna work better. How does I is yellow. I don't know which version of LOLCODE our parser was written for. Not implemented function definition. Okay, so let's try with function definitions first. That seems like a good way to start, actually, to be honest. So we have function definition, and we go to JSify.js, and we say function definition equals node blah console log of our node, and then we'll be able to see what the node actually is, or like what its properties are. So we have name is yellow and no arguments. Cool. So that means we are returning function call. So we return function with node.name, which has arguments. Right now, no arguments yet, and it returns this.compile of node.body. So each function comes with a body which uses recursion to do the rest. So if I run that, we should now get a function with arguments, or without arguments. Yes, that worked, I think. Did it work? Did it work? That's the question. Macros cast, function call, function definition, visible yellow. It didn't quite work. Let's try running it with updating the snapshot and see what happens. It didn't quite work. Why not? Why didn't body get compiled? JSify console log. Oh, that's why. Okay, now it's gonna work. We do the thing. So I was putting it in the wrong parser. So we now have a code that runs, that parses a function. Cool. So we can then go function call with arguments. Function call with args. And let's see, we can have how does I is yellow. Do we have support for, where is my JSON? Your. Okay, we do have your. Okie doke. So we have how does I is yellow. Your. How do I. No, so that's how does I is color. Your color, and we say visible color. Right? Right. And let's see what that does. There. So we're going to be calling function definition with args. That's the test name. Function. God damn it. So this is function definition. So I'm getting confused because I'm doing too many nodes at the same time, but we are making very good progress. It might not look like we're making good progress, but this is the sort of thing that then just suddenly comes together. Not implemented identifiers. Okay, so we need to implement identifiers next. Identifier. What the hell is an identifier? How do identifiers work? So we go into our JSify and we say A, B, C, D, E, F, G, I, blah, blah. So identifiers are nodes that do what? Console log of our node. And let's see, what is that? I wonder if this water is still good. Let's try it. Not bad. Cool. Not implemented identifier, but oh, identifier. Wow, identifier. Run that thing. There we go. Console log undefined. So, oh, identifier name color. So I think this should just return name. So because our identifiers are pretty simple, and because this is not an interpreter, because it's a compiler, we just need to return the identifier directly, because that's what it is. It's a variable that exists in the scope, hopefully. Return node.name. Right. So we should now get a function definition with arguments, and we will see it here. Yeah. So function is color. Oh no. Huh. Okay. What if we say how is I? Will that work? Let's see. Maybe that's the difference. How is I? Select move blur. By the way, move is an argument. Let's see. How is I? Let's see if that works. So the problem we're dealing with here is that I didn't build the parser or the lexer, so I kind of am not sure how they work, which makes things harder. Yeah, see, our parser doesn't know expecting new line, comma, and blah, 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 got error. How is I identifier your move? Strings functions. How is I is yellow? Yeah. Okay, so we're gonna have to, that's gonna be tough. We're gonna have to update the parser, because currently the parser doesn't understand function arguments, which is very annoying because we need function arguments. Yeah, I guess let's go try to implement that. We're gonna have to check how to install a local version of a project, of an npm package. So we go to random coding, lol.js. We're looking at lol.js JSON. Okay, and we look for does. How does I? We're going to change that to how is I. So how does I? How is I? And we look for how does I. Function definition. Oh, no, we don't. Okay, maybe we don't need your. So we're kind of, let's see if, I'm gonna try it without the your, and that might just work. If that just works, then we just have a special flavor of LOLCODE. Let's see. How does I is color color? Let's see. Hopefully that works. If that works, then we don't have to mess with the parser, which would be very convenient. Arr. How does I is color color? Function definition with args. Expecting new line, year. So it's saying that it needs year, but it's not working with year. So what if we just say year without defining what the argument name is? That could work. How does I is color year expecting identifier got new line? Got it. So it's expecting an identifier now. So if we say color, so how does I is color your color, which is what we are expecting to see. Now will that work? It did. No, but oh God, I'm an idiot. That's why it didn't work. So see, that's one of the things about creating a programming language or implementing a programming language, is that it's very hard to know when the bug is your code or your test code versus your implementation of the language. It's like, this reminds me of my compilers class, and it's really one of the most confusing things. And the problem is, you see here, we didn't implement function arguments yet. So let's do console log of our node, and that will tell us how the function arguments are showing up in our code. Okay, is color args color? Cool. So our arguments then are node.args map join with like that. That should work. Let's see if that works. So we will now have here a correct is color color thing. Yes. Cool. Now, who can tell me why this isn't going to work? It's not going to work because I'm going to be minifying things. So we're going to minify the arguments. So each identifier, instead of returning node.name, is going to return to lowercase, JavaScript to lowercase, to lowercase, and that might work a little better. And the reason is that JavaScript is case sensitive, which means that we want to lowercase things. So node args join, and then we want to lowercase that, which is basically going to make our implementation of LOLCODE case insensitive, I think. Yeah, so we now have is color color, console log color. Yes. So now we want a return, because that's what makes sense next. So macro test, we no longer need a test for an identifier because we already have that. But what we do need is a function definition with a return. And it's going to say found your color. So this is going to be a function that just returns whatever we return. So we're going to run function definition with return, and now we're going to get an error saying that return is not defined yet, or not implemented. Yes, return not implemented. So we go to our JSify and we say identifier function definition return equals node, which does what? Console log node run the thing, see what the properties of the node are. It shouldn't be too complicated. So it's an expression that has an identifier, which means we are returning a string called return that then compiles node.expression. So each return has an expression that then does stuff. You know, I'm starting to think that implementing this could make a very interesting video course, like learn how to build a compiler, which is a very great way to learn a lot about languages and stuff, and just programming in general. It was honestly one of my favorite courses at college. How to implement a compiler. Damn, that could be an interesting one. So now that we have that, now we actually want to be able to call our functions. JSify git status. Oh, I implemented a bunch of stuff, didn't I? Okay, so we have our macro test, go back to blah, and now let's do a function call. How does I is yellow, visible yellow, and then we say I is yellow. Okay, let's see, yarn test function call, function call minus u. Let's see if that works. I'm hoping that that was the thing. Ooh. All right. That did kind of work. So now when we are in function call, let's console log our node again so that we can see. Oh, that's the thing. It's not actually that it worked, it's that we weren't doing anything with function calls. Yeah, function calls are wrong. Let's see how our function calls implemented here. Call, identifier, arglist, argend. So function call I has a, so that's a var declaration, or really OMG WTF, some small k tanks fail. Why? Yeah, I think function calls are actually, what if function calls are in this interpreter is yellow is okay. Let's see what happens if we do that and we just don't have an argument list. Ah, yes. Cool. Okay, so that's how it's done. Again, this is our special flavor of LOLCODE. So function calls return node.name with this.compile of node.args, which again is a node. And now it's going to say that arglist is not a node that we know what to do with, isn't it? It should say that. Yes. Arglist not implemented. And let's see, what does an arglist do or look like? So arglist equals node blah console log node. Okay, is yellow undefined. Arglist has values, which is an object. Okay, that makes sense. Console log. What is node.values then? Node.values. We're basically reverse engineering LOLCODE from a compiler, from a parser. Name is. Okay. So, oh yeah, because you know what function arguments are? They're a list of expressions. So we return. Yes, we are going to return node.values.map this.compile. So we are passing each node into our own compiler yet again, and then we're joining them like that. Let's see if that works. Should work. Yes, is yellow is, but we don't actually want arguments, which means my test code is wrong. So we're just saying is yellow okay. I guess we do need to say is, don't we? Function call identifier arglist argend. So it's that's funny. The way that that's very funny. So basically, the way that our parser is implemented, or the parser that we found on the internet, it requires function arguments, which is kind of silly. Because it means that we can't have functions that don't take arguments. And that's a bug. But it's a bug that I don't want to fix right now. Is yellow is okay. So I'm going to make it so that we just ignore I is yellow okay. Oh no. Let's put in an underscore. Is yellow. What if we put a space there? What happens then? Maybe that's gonna work. Nope. So it always needs. Yeah, that's definitely a bug. But is it a bug I should fix? Let's do it this way. Function call, how does I is color your color is yellow, yellow, okay, is color visible color, run that, and that should work, I think. We'll see. It does work. See, we now have function is color color, console logs color, and is color yellow is a function call. Cool. So I'm going to commit this for now. Git status, git add source, git commit -a-m, a bunch of stuff implementing functions. Very nice. Okay, what's next? Function definition. Then next we have if statements. How do I write an if? If when if x equals win, both of win and win. Is that how? Really? if you say so, conditional input output, conditional, no, lolcode syntax, conditional, is expression operator. This is similar to if operator. Operator is one of bigger than, smaller than, same as. So we say is 3 bigger than 4. Okay, now let's see what happens if we run ifs. Yarn for test of if. Cool. So yes, I've been streaming for more than an hour, which means let's make sure that it's not my restream chat that failed. That happens a lot. But it wasn't a very interactive stream anyway. Cool. Okay, so parser parse I is 3 bigger than parse error. Really? It doesn't have bigger than? If no bigger bigger than, big binary operator, so it's bigger, not bigger, it's bigger. See, this is again me not knowing the language very well. It's hard to build a compiler for a language you don't know. Is bigger than 3, 4. Wonderful. Cool. It looks like we found a problem. So let's see, how is ord of smaller than, product of, not any of, bigger of, bigger than, return A more than B. Because this has a bunch of built-ins. That's what I'm missing, aren't I? How do I trigger built-ins? So dealing with built-ins is going to be interesting. Call function fdata built-in. Okay, what if we say evaluate if, let's see, how does if work? Okay, ifs are hard. And it's also hard to do. Let's look at the JSON implementation again and see if there is an if. Index, expression, conditional. What does O really say? O really? Okay, what if we look at the LOLCODE thingy here? Conditionals. Okay. So it's not is 3 bigger than blah. That was wrong. It's actually oh really. So oh really, oh I see, and then we say yeah really. Okay, so expression, we say 3, oh really, yeah, really, visible win, no way, visible not win, but truth. So it's truth is a win or a fail. Visible fail. Now let's see if that works. So we have an expression, then we have oh really, yeah really, a print, a no why, print, and an OIC. Right? Throw error, not implemented if. Yes, we correctly wrote the thingy. So I can now go to JSify. A, B, C, D, E, F, G. I'll just put it here. If equals node. And what does an if node have? Okay, getting really close. Ooh, I should go to bed. Damn it, I was really hoping to finish this today. So has a name condition, body, else ifs, and an else body. Condition null. Okay, is it oh really 3 then? Oh really 3? Does that create a condition? Where do I put the condition? Oh really? The traditional if-then construct is a very simple construct operating on the implicit it variable. In the base form there are 4 keywords. Both same animal and cat. Oh really? Yeah, really, visible you have a cat, maybe both. Okay. Let's see if there's an example here. So if we look at our programs, test programs, there should be an oh really here. Oh really. Not both same tape, an oh, okay. So if we say 3 and oh really, then it should have an expression, right? Hopefully. Yes. No, condition is still no. God damn it, how do I get a... Okay, but I know there's going to be a condition and stuff. So let's do that. If is going to, if should return if $name.condition, which I believe is going to be a node. Might not actually be a node. If name condition, then this is going to be else ifs. Okay, so the body here is going to be just this dot compile of name dot body. Else is $this dot compile of node dot body, node dot else body. Right. Let's see if that works. Yes, console log 3 false, but the condition is undefined, which is a problem. So let's see if we can define a condition. The way it works here both same cn. Okay, let's try. Let's see, what does the parser actually say? How is the parser implemented? Source lol.js JSON. We say, oh really, really. So oh really. No, oh really. Oh really, end of line. Yeah, really, end of line, body. Conditional inner, maybe. Simple expression. All body. Conditional inner, no way. End of. Why? Okay. Then what if we say I has a var 1, I has a var 2, both same, var 1 and var 2. Oh really? Let's see what that does. Does that give us a condition? Ooh, it did. No, it didn't. So we got both same, which is wrong. That should become a built-in expression. So we have a problem somewhere with expressions. Let's see then. Declaration, expression, identifier, if visible literal. Let's see. Console log literal and node. Let's try that. Arg list assignment, yeah. Aha. Value primitive blah. What is this thing? Yeah, so I don't know how to handle both same and stuff like that. Like, it doesn't seem to get parsed with the parser. Both same, pbin op. Yeah. This is becoming a problem. Oh, really? How does that work? Yeah. This is supposed to give me a condition. So if I say both same 2 and 3, let's see, what does that compile to? So this is where we got stuck, but yeah, see, both same gets converted to a function, which kind of makes sense, I think. I know what we're supposed to do. We are supposed to say, no, yeah, I don't know why this isn't working. Because whatever we put here should become a a condition. True if undefined. Why is that not becoming a condition? What if we say just win or really? Then it's going to error out probably. No. Yeah. Do. Oh, really? Really? Early. How is 99 bottles doing it? Different numbers. Oh, really? Yeah, really? Blah. Why? Why is this so hard? Yeah, okay. I'm gonna have to finish now. So I'm gonna stop live coding. If you're still there, thanks for watching. We're going to... Yeah, this was fun. But I might keep working on it tomorrow or the day after, but we'll see. I'm getting kind of stuck here. And I'm not sure what to do next. Git status, git commit. Let's run yarn test on everything. Let's see what happens. It might work, it might not work. Okay, it failed the command, blah. But we're getting there. We have things that work. Let's see, where are we? Okay. Yeah, I'm gonna stop live coding. Thanks everyone for watching. We will continue when we continue. Commit -a -m, getting stuck on conditionals. Git push origin master. And let's see. Cool. All right. See you guys.